There are some general rules to help us determine the running time of an algorithm. So we'll start with the time complexity, with the constant time complexity. So any statement that does not depend on the input size in any way is considered a constant complexity, O of 1. So if I told you to choose any random card from the card deck, the first random number from here, any number, they are not sorted. So you shuffle them and you choose the first one. It's very easy. You are choosing the first number and the first card. So it's very easy to choose a random one and access a specific element. Okay? And access any specific random card without having searched through the entire cards. In terms of coding, let's see the time complexity O of 1 in coding, such that system.out.println hello, or in Java, or print in C, printf, and Python. We will use many coding languages through the course, so I will make it a diversity. And this is system.out printing hello. We are not doing anything, just making a constant thing, a printing message. If we create and initialize a variable, also we are not doing anything that depends on a statement or any input size. Also, if we create a new k equal 15 times z plus 800, we are just making mathematical calculations that are not depending on any input. So the user will not able to enter anything. Everything is clarified. We have z equal to 15, so 15 times 15 plus 800. It's very simple to be calculated. This would release or result in a time complexity, the total time equal constant equal O of 1. So this is the constant time complexity O of 1. The next complexity, time complexity, is the linear time complexity, O of n. Linear running time algorithms are widespread. These algorithms imply that the program visits every element from the input. Linear time complexity O of n means that the algorithms take proportionally longer to complete as the input grows. This is very important. As the input grows, the algorithm will take more time to be completed. Let's take an example in the playing cards and then go to the coding. Example, choose the ace of hearts. Maybe if you shuffle the cards and choose by random, choose any of the cards. Maybe if you are going to, you are not at random, we are not going to choose a direct one, a direct ace of hearts. So we need to make sure that it is ace of hearts and not anything else. So we need to search all the deck for ace of hearts. If we are lucky, we can get the ace of hearts at the first card. Or we have 52 cards. We can get it at the last one or in the middle. So this complexity, time complexity, depends on the number of the cards. We start. Again, we need to choose the ace of hearts. So it is defined. We need ace of hearts. We don't need ace of spade or diamonds. We need ace of hearts. So We have 52 deck. In the deck, we have 52 cards. We need to search through the cards. Where is Ace of Hearts? If we are lucky, we can find it at the first card. But if we are unlucky, we can find it at the last card. This depends on the number of the cards. Imagine that we have 100 cards. So maybe we can find the Ace of Hearts at the first pick card or the card number 100, which is the last card. So this depends directly on the input. So as we increase the number of cards, we increase the time complexity to find a specific card. This is very important to understand. So in coding, linear time complexity means that the algorithms take proportionally longer to complete as the input growth. For example, if we have a loop for int I, with I equal to 1, and I less than or equal to n, I plus plus, and we need to print every time hello. We said that the system, when we print a message or assign variables or doing anything not related to the input, we consider it as a constant. Okay? So this loop will go through from 1 to n. It will be repeated n times. Okay? So if I enter n 10 times, 10, this printing hello will be printed 10 times. If I enter n less n equal to 1 million, so this system.out.println line will be executed 1 million times. So here we depend on the n, on the value of n. So as n value increase, the executed statements increases. And this means that the algorithms take the proportionally longer to complete as the input grows. So printing 1 million message during a time is greater than printing this message like 10 times. Okay? So this is the linear complexity. In terms of coding also and time complexity, the total time for this loop is C times n. C corresponds to the system.out.print. The C correspond to this line of code. So as I told you, system.out.print is having a value C because a constant time. And n here is from the loop because this loop will be stopped at n. So the number of execution and the number of iteration through this loop is depending on the value of n. So n, if I enter 10, it will be executed 10 times. If I enter 1 million, it will be executed 1 million times. So it depends on the n value. Okay, so this is C times n equals Cn. And according to the previous lessons that we have seen, that the higher value of n, we took it and we removed the constant that it is multiplied by n. So here in this equation we have the highest term, it is Cn, and n equal to 1, having power 1, and the multiplied constant with n is removed. We have, therefore, the O of n is the time complexity for this loop. Okay?